Hello, in this presentation, I want to show and explain you how to retrieve and export inertia matrix from part product to Excel file. Starting with an assembly, then add principal axis to existing inertia measure. Now, the last three measurements, BBLX to Z, are the bounding box dimension of the ASI. This folder contains the assembly file and all the parts. In this folder are the macros. I will use them to export data to Excel file. At running the first macro, parameters and formulas are added in assembly, as presented. They are connected to inertia volume 1, bounding box measures. But you need to be sure that inertia volume name is as presented, otherwise the parameters and formulas will not work. Running again the same macro, but this time in a part, the result will be as presented, taken from inertia volume 1. Next, I will run the second macro to delete parameters and formulas from assembly and part. Now, I will show you the macro code for adding and removing parameters and formulas. I used cases for part and product, then for each case, the length parameters are created, next added the formulas to connect with inertia volume 1 measurements. In same way, next macro will delete parameters and formulas. The third macro, when run, will export the data to the existing Excel file in this folder. The data will be added after the last used cell in column A. A message box with short data info is opened before data will be written into Excel file. Obviously, the data matched the inertia volume 1 measurements. I will bring from background the Excel file, where in row 9, the data are added into table. Excepting density, all other data are the same from inertia measurements. Because the material varies from body to body, the density cannot be computed by CATIA, and the mass is obtained by summing all individual ones, defined by inertia measurements in each body. The bounding box dimensions are useful for calculating the minimum packaging needed, or the space for storing or transporting the assembly. After switching to assembly, I will run again the macro. The data in message box corresponds to inertia volume measurements. But density is relative, calculated by ratio between mass and volume. The result was appended to Excel table, as you can see. Only the density is different from inertia volume measurement, due to previously explaining reason. Now, I will show you the macro code. Again, I use cases for part and product. In part, are defined parameters, connected to inertia, and accessed by message box and exported to Excel file, from defined location. There is defined the last used row in column A, and the cells where to export data, as presented. After export, the workbook is saved, but not closed. In product case, I reused some of already presented code, to create parameters and formulas for bounding box, then export their values to Excel file, after that they are deleted, using the previously code. A message box, indicating product data info, is defined. The Excel file and path is the same, also the cells where the data is exported, then the parameters and formulas, are deleted. The fourth macro, should be used only in part document, so I switch to one and run it. As you can observe, the part contains multiple bodies, with different material assigned. After the global inertia volume measurements, are added individual measurements for each root body. Now, the data are exported in a new empty Excel file, saved with part name, in same location as the part. In the table, are exported data corresponding for each body, but only 3 bodies have material density assigned, the other ones, including the part body, we should ignore. These data are useful, because if we have hidden bodies, or construction ones, not disabled, then their mass will be added to part, resulting a bigger one, not the real one. This will have also a big impact, into the assemblies that contain them, increasing the final product mass, and give incorrectly measurements in CATIA. So, these data in file, are useful to detect eventually errors, and correct them. I can't export the bounding box for each body, only for the part, due of using bounding box parameters, as presented before, connected only with overall inertia measurement. So, if there is a hidden body or construction one, with bigger dimensions, this will have also impact in establishing the correct bounding box dimensions. For this, you can't blame CATIA. If the designer forgets unused data, the measurements will be inexact, and future data can create issues. You can observe that bodies used in Boolean operation does not have individually material assigned, the density retrieved by macro is 1. But their mass is included in parent body, and calculated with parent material density. I will show you next the code for this macro. First, since this macro is working only for part, there is an attention message box, if the current document is not 1. Next, are define the content and font, of the first row in Excel. Next are defined, the inertia parameters, and the cells and columns where to export the results. It's possible to export also the COG data, center of gravity, if it's needed. The file name and path are taken from active CATIA document, and the Excel file is saved after was filled. The Excel file is in same location with part file, as you can observe. The relative density is not so useful, since is obtained as the ratio between mass and volume. Next, I will run the fifth, the final macro, that works both on part and product. The data are exported in an Excel file, overwriting the existing one. I will switch next to assembly and run again the macro. First, a message box with short product info appears. After closing it, the data are exported to Excel file and saved in same location with the current ASCII. As you can observe, only the density is different. CATIA computed 1, and in Excel is ratio between mass and volume. The Excel file is in same location as CATIA product, with same name. Next, I will show you the code of the final macro. It uses, of course, cases for part and product. Next is a combination of previously macros. But the data are exported to individual Excel file, with same name and path, as original CATIA file. So, for the part, is the same code in previous macro, number 4, and for product is used almost the same code, like in macro 3, excepting the saving to individual file, instead of already defined one. Here is the message box, with product info. Of course you can suppress it. Now, I will open in parallel both exported Excel files to see the differences. I hope you will find useful this presentation. Until next one, I wish you all the bests.